Hi, today we are going to deal with problems related to arithmetic progression. Before moving into the problems, we need to understand certain formulas to solve problems related to arithmetic progression. So let's see what are the formulas we need to know. Okay, in a arithmetic progression, a series will be given. The first term of the series is usually represented with the symbol A. So A represents the first term of an arithmetic progression series. D is the common difference between each succeeding number in the series. To find the common difference, what we can do is we can subtract the two consecutive numbers from the series. So that is nothing but D is equal to an minus an minus 1. Okay. Next is L or an. This is nothing but a general term in a series is represented as an or L. Also, the last term of the series of an arithmetic progression is L, represented with L. Okay. To find the nth term of a series, we use this formula. An is equal to a plus n minus 1 into d. Want to find a value of the certain position, we can use this formula to find the value of it. Next is the sum of n terms formula. For that, it is represented as Sn. The formula to find the sum of a first n series of AP is n by 2 into 2a plus n minus 1 into d. So with this formula we can find the sum of first n terms of an AP. Sn formula can also be written as Sn is equal to n by 2 into a plus an. An is nothing but the last term of the series. Now let's move into solving certain problems so that we can understand it more accurately. Here, write first four terms of the AP if A is equal to 10 and D is equal to 10. So the first term is nothing but A is equal to 10. The common difference D is also 10. So first four terms of an AP looks like A plus D, A plus 2D, A plus 3D. So we are going to substitute here and find the first four terms. So A is nothing but 10. A plus D is 10 plus 10. A plus 2D is 10 plus 2 into 10. Then the next term is 10 plus 3 into 10. So the series is like 10. 10 plus 10 is 20. 10 plus 20. 2 into 10 is 20. So 10 plus 20 is 30. 10 plus 30 is 40. And so on. So the first four terms are 10, 20, 30 and 40. Let's do another problem. For the following APs, write the first term and common difference. So here the series is given. Now we are going to find the first term and the common difference. So first term is nothing but minus 5. So A is equal to minus 5. We are going to find the common difference D. We know that D is nothing but an minus an minus 1. So nothing but we are going to subtract the consecutive numbers in the series. So here what we are going to do is we are going to take a2 minus a1. So which is nothing but minus 1 minus minus 5. So this is nothing but minus 1 plus 5 which is equal to 4. Next is we are going to subtract a3 from a2. So it is nothing but 3 minus minus 1. Minus into minus is plus. So this is 3 plus 1 which is equal to 4. Next is what we are going to do is a4 minus a3. So a4 minus a3 is equal to 7 minus 3 which is equal to 4. So here you can see that the common difference between each consecutive terms is 4. So therefore the common difference D is equal to 4 and the first term A is equal to minus 5. Let's move on to another problem. Which term of the AP the series is given is 78. So the value is given. Now we are going to find the position of this value. That is nothing but the n value. For that, the formula we are going to use is an is equal to a plus n minus 1 into d. So here we need certain data. What are the data we are given is, it is given in the question is a is equal to 3. The first term is 3. D is equal to, we can find it out by subtracting the consecutive. So 8 minus 3 is nothing but 5. 13 minus 8 is nothing but 5. 18 minus 13 is nothing but 5. So the common difference is 5. Okay. N is what we are going to find, and the value of the position an is given as 78. So we are going to substitute these data into the formula and find the nth position. So an is 78, which is equal to a is 3 plus n is what we are going to find. So n minus 1 into d is nothing but 5. So here when this 3 comes that side, it becomes 78 minus 3 is equal to n minus 1 into 5. So 78 minus 3 is 75. When I bring this 5 to this side, it becomes to the denominator, and now I am left out with n minus 1. So when we cancel these both, we are getting 15 is equal to n minus 1. When this minus 1 comes that side, it becomes 15 plus 1 equal to n. Therefore, n is equal to 16. So the 16th term of this series is 78. Let's do another problem. How many 3-digit numbers are divisible by 7? The smallest 3-digit number divisible by 7 is 105, and the greatest 3-digit number divisible by 7 is 994. Now what we are going to find is the digits between these two which are divisible by 7. So that is what we are going to find. Here we know that a is equal to 105, that is the first term, and the last term an is 994. And the common difference is obviously 7 because it is divisible by 7. It is a 7 table. So the common difference obviously will be 7. Now what we are going to find is the position of 994, because this is the last number that is divisible by 7. So if we find the nth value, the position of 994, then we can find how many 3-digit numbers that are divisible by 7. So let's substitute in the formula. An is equal to a plus n minus 1 into d. So here an we know that it is 994, which is equal to a is nothing but 105 plus n is what we are going to find. So n minus 1, d is 7. So when I bring this 105 to this side, it is 994 minus 105, which is equal to n minus 1 into 7. So 994 minus 105 is 889. So when I multiply the 7 inside, it is 7n minus 7. So if I bring the 7 this side, it becomes 889 plus 7, which is equal to 7n. So 889 plus 7 is nothing but 896, which is equal to 7n. So I need 7. So what I have to do is bring the 7 to this side. So 896 by 7 is equal to n. So when I cancel these both, I will be getting n is equal to 128. So therefore, there are 128 3-digit numbers that are divisible by 7.